Professor Stephen Hawking might have died before the James Webb Space Telescope finally launched. Still, due to the vast space legacy of the late physicist, many hours of the new space telescope will be dedicated to proving some of his theories. One of such theories is the very last one Hawking worked on before his death, in which he argued about a multiverse theory that implies an exact copy of you existed in a parallel universe. What is the multiverse theory, and will the James Webb Space Telescope finally prove Stephen Hawking's multiverse theory? Stephen Hawking died in 2018, missing the launch of the James Webb Space Telescope by more than 3.5 years. That was thanks to multiple delays that pushed the launch date from between 2007 and 2011. It also gulped up $10 billion, about 10 times the initial budget. However, following a successful launch and deployment of its components, this powerful space telescope will undergo several months of calibrating and testing before settling down to work. Thanks to the large 6.5-meter giant mirror that had to be folded during launch, the telescope will be able to peer into the atmosphere of planets outside our solar system and peek through massive clouds of dust to watch the birth of new stars and planetary systems. JWST will be able to gather and reflect light from the early universe. The universe is thought to be around 13.8 billion years old, and JWST will be able to observe light from the earliest stars and galaxies close to the Big Bang. The JWST is an infrared telescope, meaning it uses infrared radiation to detect objects in space. It is able to observe celestial bodies such as stars, nebulae, and planets that are too cool or too faint to be observed in visible light, that is, what is visible to the human eye. According to NASA, infrared radiation can also pass through gas and dust, which appear opaque to the human eye. This is different from the world-famous Hubble telescope, which sees visible light, ultraviolet radiation, and near-infrared radiation. In order for the instruments aboard to work, they need to be kept at extremely cold temperatures, minus 370 degrees Fahrenheit or lower. The large sunshield protects the telescope from the heat of the sun and keeps the instruments cold. According to a report conducted by an independent review board in 2018, there were 344 single-point failures, or steps that needed to work for the mission to succeed. However, the telescope was tucked inside the nose of an Ariane 5 rocket and launched safely from the European Space Agency's spaceport in French Guiana in December last year. It separated from the rocket after the launch and began unfolding. According to NASA, about 30 minutes after the launch, the first deployment took place as the solar panels unfolded so the telescope could get power from the sun. Because of JWST's capabilities, many astronomers are vying for time with the telescope. The Space Telescope Science Institute, which oversees science operations on Hubble and JWST, had sent out a call to astronomers for proposals on how they'd like to use James Webb, with 6,000 hours of observation time up for grabs. The lucky ones have now received approvals for their projects, and we look forward to the wealth of knowledge they will enrich us with. There is plenty of time for the JWST to unlock the deep secrets of the universe, with about 20 years of operation guaranteed by the amount of fuel aboard the space telescope. With the JWST safely delivered to its location about 1 million miles away from the Earth, it is time to confirm one of Hawking's most intriguing theories, the multiverse concept. The theory is special because it was the last one published by the professor. In fact, that final research from the sharp mind was submitted for publication just 10 days before his death. In the paper titled A Smooth Exit from Eternal Inflation, which he co-authored with Thomas Hertog, a physicist at the Catholic University of Leuven in Belgium, Hawking laid out a theory on the origin of the universe that might settle a few lingering questions. However, despite being his last work, the paper was actually a final look at one of his earliest theories. In fact, if the JWST eventually helps prove the existence of the multiverse, it will make the scientists behind it likely candidates for a Nobel Prize. However, since Nobel Prizes cannot be awarded posthumously, Hawking would be ineligible to receive it. What is the multiverse theory, and what did the late physicists have to say about it? The multiverse theory suggests that our universe, with all its hundreds of billions of galaxies and almost countless stars spanning tens of billions of light years, may not be the only one. Instead, there may be an entirely different universe distantly separated from ours, and another, and another. In fact, this mind-bending theory suggests there may be an infinity of universes, all with their own laws of physics, their own collections of stars and galaxies, and maybe even their own intelligent civilizations. So basically, our universe could just be one member of a much grander, much larger multitude of universes, a multiverse. However, it gets, as some folks will say, creepier because the implication of the multiverse is the existence of doppelgangers or copies. According to the logic, if there really are an infinity of universes but a finite number of ways to arrange particles in any individual universe, then the same patterns are destined to be repeated eventually. That would mean that at some incredible distance, there would be an exact copy of you watching the exact replica of this video. And because there would be an infinite number of universes, there would be an infinite number of these exact scenarios, all happening at the same time. The concept of the multiverse arises in a few areas of physics and philosophy, but the most prominent example comes from the inflation theory. Inflation theory describes a hypothetical event that occurred when our universe was very young, less than a second old. In that brief amount of time, the universe underwent a period of rapid expansion, inflating to become many orders of magnitude larger than its previous size. The inflation of our universe is thought to have ended about 14 billion years ago. However, inflation does not end everywhere at the same time. It is possible that as inflation ends in some regions, it continues in others. Thus, while inflation ended in our universe, there may have been other much more distant regions where inflation continued and continues even today. Individual universes can pinch off of larger, inflating, expanding universes, creating an infinite sea of eternal inflation filled with numerous separate universes. In this eternal inflation scenario, each universe would emerge with its own laws of physics, its own collection of particles, its own arrangement of forces, and its own values of fundamental constants. This might explain why our universe has the properties it does, particularly the properties that are hard to explain with basic physics, such as dark matter or the cosmological constant. According to some scientists, the biggest piece of evidence for the multiverse is that life exists, particularly intelligent life capable of making cosmological observations. They look at it this way: certain aspects of our universe seem special and vital for supporting life, such as the longevity of stars, the abundance of carbon, the availability of light for photosynthesis, and the stability of complex nuclei. But all these features are typically not the case if you get handed a random universe. The multiverse offers one explanation for why all these features are favorable in our universe, which is that other universes exist as well. Still, we observe this one because it's capable of supporting complex life. However, according to Hertog, Hawking was not satisfied with this state of understanding of the multiverse. So he asked Hertog to join him to try to tame the universe. The pair then worked to develop a method to transform the idea of a multiverse into a coherent, testable scientific framework. Hawking's final paper suggests a framework for understanding the universe that would render the multiverse finite, countable, and subject to meaningful engagement via the tools of science. Interestingly, Hawking helped develop the theory that led to the idea of infinite parallel universes, that is, the eternal inflation theory. But he admitted he had never been a fan of the multiverse in an interview. He is quoted as saying, "The usual theory of eternal inflation predicts that globally our universe is like an infinite fractal with a mosaic of different pocket universes separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, which together would form a multiverse. But I've never been a fan of the multiverse. If the scale of different universes in the multiverse is large or infinite, the theory can't be tested." Hawking and Hertog relied on string theory, a branch of physics that tries to reconcile quantum physics with gravity and Einstein's theory of relativity. They came up with a new idea of eternal inflation that relies on a boundary at the beginning of time. The idea suggests that when we trace the evolution of our universe backward in time, at some point we arrive at the threshold of eternal inflation, where our familiar notion of time ceases to have any meaning. Starting from that boundary, the new theory predicts a finite structure of universes emerging from the Big Bang. If this theory is proved true, it would suggest that other universes like our own could have emerged at that point, and there could even be primordial gravitational waves that match the inflation of the universe. But this new model is still far from proven, and physicists will need more data and a better understanding of string theory before that's possible. The paper also implies that it might be possible to test this theory. However, the existing instruments then were not sensitive enough to find evidence of this theory, but that does not stop scientists from trying. Physicists could look for evidence of other universes using tools designed to measure ripples in space-time, also known as primordial gravitational waves, that would have been generated by the universe's initial expansion from the Big Bang. Other scientists have tried to find more physical, hard evidence for the multiverse's existence. For example, if a neighboring universe happened to be close to ours long ago, it may have collided with our universe, creating a noticeable imprint. That imprint could be in the form of distortions in the cosmic microwave background, that is, the light left over from when the universe was 1,000,000 times smaller than it is today. Let's hear what you think of Hawking's theory of the multiverse in the comments section below.